como yo en Luca Bachi, bailando completo vestido Versace.
Previously in the robot
I wasn't looking at the
workshop, we modded Sting's drivetrain with sensors, and we developed the bulk of our maze-solving algorithm.
Let's jump in.
If you're not nerdy girls, there are some parts you will need in addition to the dual control or programming control starter kits. All those additional parts can be found in the description box below. Step 1, parts you need: 2 16-hole rails, 4 1/2-inch 832 screws, and 4 nylock nuts. You are gonna take those 2 rails and screw them into the ends of your front piece like so. Feel the pain spike through your fingers as you twist on those nylock nuts. Step 2, parts you're gonna need: 4 3/8-inch 832 screws, 4 Kep's nuts, and 1 15-hole C-channel. Take the C-channel and screw it onto the front of the 2 rails using the 2 top holes. Screw on the Kep's nuts nice and tight, and though Kep's nuts loosen easier than the nylock nuts, they'll get the job done for this piece. Step 3, you're gonna need a 393 motor, a 3-inch shaft, a 12-tooth gear, 2 bearing flats, 3 shaft collars, and 2 1/2-inch motor screws, and 2 pop rivets. You're gonna attach a bearing flat to the bottom of the C-channel, 5 holes in from the left, and you're gonna secure that 393 motor to it with motor screws in the right and center holes. After that, you're gonna place another bearing flat directly across from it, and you're gonna use pop rivets in the right and center holes to secure. After that, slide the shaft through the left bearing flat holes into a shaft collar and then into that motor. You're gonna secure the shaft collar against the C-channel. Up top, you're gonna make a gear sandwich and tighten those shaft collar bread slices. Step 4, parts you're gonna need: a 3-inch shaft, a 60-tooth gear, a 20-hole C-channel, 2 bearing flats, 2 1/2-inch 832 screws, 2 Kep's nuts, 4 pop rivets, and 4 shaft collars. Attach the 2 bearing flats with pop rivets directly across from each other immediately next to the ones we just attached. Then slide the shaft through and into a shaft collar at the bottom, and you're gonna tighten that shaft collar like your life depends on it. Up top, you're gonna slide on a shaft collar, then the gear, the bottom of the C-channel 3 holes in, 2 shaft collars, and then the top of the C-channel. You're gonna tighten those shaft collars against all of the edges, and you're gonna secure that C-channel to the gear with the screws and Kep's nuts. You can see that the arm mechanism has a 5-to-1 gear ratio, 60 teeth on the driven or output gear, and 12 teeth on the driving, aka input gear. Though Vex has gear ratio expressed as number of teeth on the driving gear to number of teeth on the driven gear, the majority of resources that we've come across have it expressed the other way around, driven to driving. Using that way of doing things, we have 60 teeth on driven to 12 teeth on driving, which simplifies down to 5-to-1. When that driven gear is larger than the driving gear, you're gonna have more torque and less speed. And we need some serious torque for tipping cows, am I right? Step 5, you're going to need a finger hand with a screw hole drilled near the top, a 3/4-inch 832 screw, and a Kep's nut. You know what to do. You're gonna screw that finger hand through the first top hole of the C-channel arm and secure. You're welcome. Step 6, parts you're gonna need: 1 motor controller. Plug your motor into the 2-wire motor controller cable, then plug the end with 3 wires into the Cortex. We're doing port 2. The motor controllers help regulate speed. Make sure that the black is closest to the edge. Before you move on to coding though, be sure to get your wiring inspected by the official electrical inspector. I'd say we're pretty much ready to code. Let's go. All right, so I've opened up the same file that we were just working on that has all the maze navigation code. And all we're gonna do now is make a special function for the arm swinging. Then we will call it up the appropriate places in our algorithm. So real quick, make sure we have USB only checked and that our system is Vex 2.0 Cortex. Now let's add the arm motor to our hardware. Under motors and sensor setup, the motor we have is plugged into port 2. I'm gonna call it arm motor. And just so that we can think of swinging out as positive, I'm going to reverse that shiz. Hit apply and okay, and then save AF. Let's create a new function up here to add to our magical function list. I'm gonna call it arm swing, and then down here, let's set it up. Now, this is assuming that you are always starting with your arm swung all the way back against the other shaft. So let's have it swing forward for like 1.5 seconds at a slowish speed. And we're gonna have it stop for 1/10 of a second, and then we are gonna take it back, but for a slightly shorter amount of time so it doesn't run into that shaft. So the places in the main function that we want to call this up are going to be right before each turn, after it sees a wall, but before it turns left in case there's a cow right on the other side of that first wall. And then after it turns left, if there's still a wall there might be a cow on the other side of that wall. You don't know, so we're going to swing. Then after it turns right, it's also going to swing just in case. So let's save, test it out, and adjust those arm turning numbers until you have it swinging just the way you want it. I do believe it is time for the battle. Your main objective is to navigate all of Angel Horse Maze and tip every single last cow. You have 3 love taps to use when you deem it necessary.
Use the JCPenny accessory very wisely.
Let's
What's up, you guys?
go.
Bye.